Welcome to episode 29. Today we are building our second final project, a powerful command line task manager. This practical application will help you organize your life using Python. We'll create a complete task management system where you can add tasks, mark them as complete, delete them, view them by priority, and save everything to a file so your tasks persist between sessions. This project combines file handling, data structures, user input, and command line interfaces. Let's build a productivity tool you'll actually use. Let's explore what we're building. Our task manager will be a command line application that lets you manage your to-do list efficiently. It will support task creation, completion tracking, prioritization, and persistent storage. Everything you need to stay organized. Our task manager has 8 powerful features. First, add tasks with descriptions and priority levels. Second, view all your tasks or filter by completion status. Third, mark tasks complete when you finish them. Fourth, delete tasks that are no longer relevant. Fifth, sort tasks by priority so you tackle important items first. Sixth, save all tasks to a file so they persist between sessions. Seventh, automatically load your tasks when you start the program. Eighth, an interactive menu makes the app easy to use. This is a professional productivity tool. Let's start coding. The foundation is our task class. Each task is an object with properties like description, priority, completion status, and creation date. We'll use object-oriented programming to encapsulate all task-related data and behavior in one place. We start by importing datetime to track when tasks are created and completed. The task class init method takes a description and an optional priority with a default of medium. We store the description and priority as instance variables. The completed flag starts as false, new tasks are incomplete. We capture the creation timestamp using datetime.now. The completed attribute starts as none and will be set when the task is marked complete. This gives us complete tracking of each task's life cycle. Now let's add methods to change task status. We need to mark tasks as complete or incomplete. These methods will update the task state and track when completion happens. The markComplete method sets the completed flag to true and records the completion timestamp using datetime.now. This lets us track when tasks were finished. The markIncomplete method does the opposite, sets completed to false and clears the completion timestamp. This is useful if you accidentally mark something complete or a task needs to be reopened. The toggle status method is a convenience function that checks the current status and switches it. If completed, mark incomplete. If incomplete, mark complete. One method handles both cases. This is good API design. Next, we need string representations of our tasks. The str method will format tasks for display, and we'll add a method to convert tasks to dictionaries for file storage. These methods handle data presentation and serialization. The str method creates a formatted string representation of the task. We use a checkmark if completed, an X if not. We format the creation date using staff time with year, month, day, and hour, minute format. The result string shows the status symbol, description, priority, and creation date. If the task is completed and has a completion timestamp, we add that too with the same date formatting. The result is a clean, informative one-line summary of the task. When you print a task object, Python automatically calls this str method to convert it to a string. Now for serialization. We need to convert tasks to dictionaries so we can save them to JSON files. We'll also create a class method to rebuild task objects from dictionaries when loading from files. The toDict method converts the task to a dictionary with all its properties. We use ISO format on datetime objects to convert them to ISO standard strings that JSON can handle. For completed at, we use a conditional expression. If it exists, convert it. If none, keep it none. The fromDict class method does the reverse. It creates a new task object from a dictionary. The class method decorator means we call it on the class itself, not an instance. We create a task with description and priority, then manually set the other properties. We use datetime.fromISO format to convert ISO strings back to datetime objects. These two methods enable seamless serialization and deserialization for file storage. Now let's build the Task Manager class. This class manages a collection of tasks and handles all operations like adding, deleting, viewing, and saving. It's the controller that orchestrates everything. We import JSON for file handling and OS to check if files exist. The task manager in it takes a file name with default tasks.json. We store the file name and initialize an empty task list, then we immediately call load tasks to read any existing tasks. The load tasks method checks if the file exists using os.path.exists. If it exists, we open it and use json.load to read the data. We use a list comprehension with task.fromDict to convert each dictionary back to a task object. We wrap this in try except to handle corrupted files gracefully. If the file doesn't exist, we print a friendly message and start with an empty list. This ensures tasks persist across sessions. Now let's add the save method. This writes all tasks to the JSON file, ensuring your data is preserved. We'll call this after every modification to keep the file synchronized. The save tasks method converts all tasks to dictionaries using a list comprehension that calls to dict on each task. We wrap everything in try except for error handling. We open the file in write mode and use json.dump to write the data. The indent parameter of 2 makes the JSON file human readable with nice formatting. We print a confirmation message showing how many tasks were saved. If anything goes wrong, we catch the exception and print an error message. This method is called after adding, deleting, or modifying tasks to keep the file in sync with memory. Let's implement the add task method. This creates a new task object and adds it to our collection. It's the most fundamental operation, building your to-do list. The add task method takes a description and optional priority. First, we validate that the description isn't empty by checking if it exists and if its stripped version has content. Second, we validate the priority is one of our 3 allowed values: high, medium, or low. If either validation fails, we print an error and return false. If validation passes, we create a new task object with the stripped description and priority. We append it to our tasks list, save to file immediately, and print a success message with a check mark. We return true to indicate success. Input validation prevents bad data from entering our system. Now let's add methods to view our tasks. We need to display all tasks, or filter by completion status. We'll also add sorting capabilities to organize tasks by priority. The viewTasks method accepts optional parameters for filtering and sorting. First, we check if there are any tasks at all. If not, print a friendly message and return. Then we apply filtering based on the filter by parameter. If it's complete, We use a list comprehension to get only completed tasks. If incomplete, we get only incomplete tasks. Otherwise, we use all tasks. After filtering, we check if any tasks remain. If not, print a message indicating no tasks matched the filter. This handles the edge case of filtering with no matches. Now we continue the view tasks method by sorting and displaying the tasks. We'll handle priority sorting and format the output beautifully. If sort by priority is true, we sort the filtered tasks. We create a priority order dictionary mapping high to 0, medium to 1, and low to 2. We use the sort method with a lambda that looks up each task's priority in this dictionary. This sorts high first, then medium, then low. Next, we display the tasks with beautiful formatting. We print a line of equal signs. Center the word tasks using string formatting with caret for center alignment. And another separator. We enumerate through filtered tasks starting from 1, printing each with its number. The task object automatically uses its str method for nice formatting. We close with a separator and total count. The result is a professional-looking task list. Let's add the delete task method. This removes a task from the list by its index. Users will select tasks by number, making deletion intuitive and easy. The delete task method takes an index parameter, the task number users see in the list first. We check if there are any tasks to delete. If not, print a message and return false. Next, we validate the indexes within the valid range, between 1 and the length of the tasks list. Remember, users see 1-based numbering but Python uses 0-based indexing. If valid, we use pop with index -1 to remove and return the task. We save immediately, print a success message showing what was deleted, and return true. If the index is invalid, we print an error showing the valid range and return false. This prevents crashes from invalid indices. Now let's add the toggle task method. This marks tasks complete or incomplete. Users can easily check off finished tasks or reopen ones that need more work. The toggle task method is similar to delete task but changes status instead of removing. It takes an index, checks if tasks exist, and validates the index is in range. If valid, we get the task at index -1. Call its toggle status method to flip between complete and incomplete. And save immediately. We create a status string that says, complete, or incomplete, based on the new state using a conditional expression. We print a success message showing the new status and task description. If the index is invalid, we print an error with the valid range. This makes completing tasks as easy as entering a number. Let's add utility methods for statistics. These will show how many tasks are complete, incomplete, and organized by priority. Users can see their productivity at a glance. The getStatistics method calculates various metrics about our tasks. Total is simply the length of the tasks list completed uses a generator expression with sum. We iterate through tasks and count how many have the completed flag set to true. Incomplete is total minus completed, simple subtraction. For the by priority breakdown, we initialize a dictionary with counts of 0 for each priority level. We iterate through all tasks and increment the appropriate priority counter. Finally, we return a dictionary containing all these statistics. This structured data can be used for reports or dashboards. Now let's add a method to display these statistics in a beautiful format. This will give users a dashboard view of their productivity. The display statistics method calls getStatistics to fetch the data. then formats it beautifully. We print a centered header with equal sign separators. We show total tasks, completed tasks with a percentage calculation, dividing completed by total and multiplying by 100. Formatted to one decimal place. We use a conditional expression to avoid division by 0 if there are no tasks. We show incomplete count, then iterate through the by priority dictionary to display counts for each priority level. The result is a clean dashboard that shows productivity at a glance. Now for the user interface. We'll create an interactive command line menu that lets users choose actions. This is the front end that makes our task manager easy to use. Let's build the menu display function. The display menu function shows users all available options. We print a centered header saying Task Manager with equal sign separators. Then we list 8 numbered options. Add task, view all tasks, view complete tasks, view incomplete tasks, toggle task status, delete task, view statistics, and exit. Each option is clearly numbered so users can simply enter a number to choose. The formatting creates a professional-looking menu that's easy to navigate. This function will be called repeatedly in our main loop. Let's create helper functions for getting user input. These will prompt users for task details and validate their input to prevent errors. The getTaskDetails function prompts the user for a task description and priority. We use input to get the description and strip whitespace. If it's empty, we return none for both values to indicate cancellation. We print the available priority levels. Then prompt for priority with a default of medium. If the user presses enter without typing, we use medium. If they enter an invalid priority, we print a warning and default to medium. We return both the description and priority as a tuple. This function handles all the input validation for task creation. We also need a function to get task indices from users. This will validate that users enter valid numbers when selecting tasks to modify or delete. The getTaskIndex function takes a prompt message with a default value. It tries to convert the user's input to an integer using the int function. This is wrapped in try except because if the user enters text like hello, int will raise a value error. If conversion succeeds, we return the index. If it fails, we catch the value error, print a friendly error message, and return none. The calling code can check for none to know the input was invalid. This defensive programming prevents crashes from invalid input. Now for the main function. This is the heart of our application. It creates the task manager, displays the menu, and processes user choices in an infinite loop until they choose to exit. The main function starts by printing a welcome banner. We create a task manager instance which automatically loads existing tasks from the file. Then we enter a while true loop. This runs forever until we explicitly break out. Inside the loop, we display the menu and get the user's choice as a string. If they choose 1 for add task, we call getTaskDetails to prompt for the task information. If description is not none, meaning the user didn't cancel, we call manager.addTask with the description and priority. Otherwise, we print a cancellation message. This pattern of prompting, validating, and acting repeats for each menu option. Let's continue the main function with options to view tasks. Users can see all tasks, only complete ones, or only incomplete ones. We'll also add optional priority sorting. For choice 2, viewing all tasks, we ask if the user wants to sort by priority. We convert their answer to lowercase and check if it equals y. This boolean is passed as the sort by priority parameter. For choice 3, viewing complete tasks, we do the same but add filter by equals, complete. For choice 4, viewing incomplete tasks, we filter by incomplete. Each call to view tasks has different parameters, giving users flexible viewing options. They can see everything, filter by status, and optionally sort by priority. This makes finding specific tasks easy. Now let's add options to modify tasks. Users can toggle completion status or delete tasks entirely. These operations need the task number, which we get using a helper function. For choice 5, toggling task status, we first display all tasks so the user can see the numbers. We call getTaskIndex with a custom prompt asking which task to toggle. If we get a valid index, not none, we call manager.toggleTask. For choice 6, deleting a task, we also show all tasks first we get the index. Then add an extra safety step. We ask for confirmation. Deleting is destructive, so we prompt, "Are you sure?" and only proceed if they answer, "Why?" If confirmed, we delete. Otherwise, we print a cancellation message. This prevents accidental deletions. Finally, let's complete the main function with statistics display and exit option. We'll also handle invalid menu choices gracefully. For choice 7, we simply call display statistics to show the productivity dashboard. For choice 8, exit, we print a saving message. Explicitly call save tasks to ensure everything is persisted. Print a goodbye message, and break out of the while loop, ending the program. The else clause handles invalid choices if the user enters anything other than 1 through 8. We print an error message. After processing any choice except exit, we pause with press enter to continue. This lets users read the output before the menu reappears. This completes our interactive command line interface. Don't forget the Python idiom to make our script executable. This allows running the file directly. The if name equals main guard checks if the script is being run directly versus being imported as a module. If run directly, name will be main. So we call our main function. This is a Python best practice that makes your code reusable as both a standalone program and an importable module. Now our task manager is complete and ready to run. Let's see our task manager in action. I'll show you a typical user session demonstrating all the features. Watch how the application flows and how users interact with it. When we run the program, it prints a welcome banner and loads existing tasks. The main menu appears with all 8 options. The user enters 1 to add a task. They're prompted for a description. Finish Python project. Then they're shown the priority options and enter high. The system confirms the task was added with a check mark and saves it to the JSON file. The task now exists in memory and on disk. Let's add more tasks and then view them. Watch how the system handles multiple tasks and displays them beautifully. We add 2 more tasks. Review code, with medium priority, and buy groceries, with low priority. Then we choose option 2 to view all tasks. We answer yes to sort by priority. The system displays all 3 tasks in a beautifully formatted table. They're sorted by priority. High first, then medium, then low. Each task shows its status with an X for incomplete. The description, priority, and creation timestamp. The total count appears at the bottom. Notice how professional the output looks with aligned columns and separators. Now let's complete a task and delete another. This demonstrates the task lifecycle, from creation to completion to deletion. We choose option 5 to toggle task status. After seeing the list, we enter task number 3 for buy groceries. The system confirms it's now complete with a check mark. Then we view complete tasks only by choosing option 3. We see just the one completed task, now showing the checkmark symbol and the completion timestamp. Finally, we choose option 6 to delete a task. We select task number 2. Review code. The system asks for confirmation to prevent accidents. We confirm with Y, and the task is deleted. The system confirms the deletion. Our task list is now smaller. Finally, let's view statistics to see our productivity, then exit the application gracefully. We choose option 7 to view statistics. The dashboard shows we have 2 total tasks. One completed, which is 50%, and one incomplete. The priority breakdown shows one high priority task and one low priority task. This gives us a quick overview of our productivity. Finally, we choose option 8 to exit. The system saves all tasks to the file, prints a goodbye message, and terminates. Looking at the JSON file, we see our tasks stored in a readable format with all their properties preserved. When we run the program again, these tasks will be automatically loaded. Our data persists. Let's visualize how our project is organized. Understanding the file structure helps you see how all the pieces fit together in a real application. Our project has a simple, clean structure. The main file is taskmanager.py, which contains everything: the task class, task manager class, helper functions, and the main function. The tasks.json file is auto-generated when you first add a task. You don't create it manually. It stores all your task data in JSON format. Optionally, you can add a README file with documentation explaining how to run the program, what features it has, and usage examples. This structure is perfect for a single file application. For larger projects, you'd split classes into separate files. But for now, having everything in one file makes it easy to understand and share. Want to take your task manager to the next level? Here are exciting features you could add to make it even more powerful. These extensions will challenge you and teach advanced concepts. First extension: add due dates and reminders. Modify the task class to include an optional due date parameter. Add in is overdue method that checks if the current time is past the due date, but only if the task isn't completed. Add a days until due method that calculates how many days remain using time delta arithmetic. You could enhance the view tasks method to highlight overdue tasks in red, show upcoming deadlines, and sort by due date. Add a reminder feature that lists tasks due within the next 3 days. This makes your task manager much more useful for time-sensitive work. Second extension: add categories and tags. Modify the task class to include a tags list, multiple tags per task like work, urgent, personal. Add methods to add tags and check if a task has a specific tag. In Task Manager, add a filter by tag method that returns all tasks matching a tag using a list comprehension. Add get all tags to show users what tags exist, using a set to collect unique tags from all tasks. This enables powerful organization. You could view all work tasks or all urgent tasks. Add a menu option to filter by tag, making it easy to focus on specific categories. Third extension: add subtasks and dependencies. Modify task to include a subtasks list containing other task objects. Add an add subtask method that creates and appends a new subtask. Add get completion percentage to calculate progress, if there are no subtasks. Return 100 if complete. 0 if not. With subtasks, calculate what percentage are complete. Add can complete to check if all subtasks are done. You shouldn't complete the parent until all subtasks finish. This enables breaking large tasks into smaller pieces. You could display subtasks indented under their parent, show progress bars, and enforce completion order. Fourth extension. Add search and export features. Implement keyword search to find tasks containing specific words in their descriptions. Add CSV export so users can analyze tasks in Excel or Google Sheets. Add PDF export using libraries like Report Lab for professional printouts. Generate weekly or monthly reports summarizing completed tasks and productivity. Add backup and restore to prevent data loss, maybe automatic backups every week. Add import capabilities to bring in tasks from other formats like CSV or even other to-do apps. These features make your task manager enterprise ready. Even more possibilities. Add data visualization with Matplotlib to create charts showing productivity trends over time. Build a web interface using Flask or Django so you can access tasks from any browser. Add Cloud Sync to Dropbox or Google Drive so your tasks follow you across devices. Implement desktop notifications using libraries like Plier to pop up reminders when tasks are due. Add multi-user support with accounts and shared task lists for team collaboration. The foundation you built is solid enough to support all these features. Start simple and build up. Let's review the important programming concepts you mastered building this task manager. These skills are transferable to any software project you tackle. You mastered object-oriented programming with encapsulation in task and task manager classes. Methods that bundle behavior with data. And special methods like init and str. You learned file handling with JSON serialization to convert objects to JSON and back. Safe file reading and writing with error handling. And persistent data storage that survives program restarts. You worked with data structures including lists for task collections, dictionaries for JSON conversion, and datetime objects for timestamps. You designed user interfaces with menu-driven interactions, input validation to prevent errors, and clear feedback so users know what's happening. These are professional development skills. There are even more important concepts you practiced. Let's continue reviewing the skills you developed. You practiced error handling with try-except blocks that catch failures without crashing. Input validation that prevents bad data entry. And defensive programming that anticipates problems. You mastered string formatting with F-strings for clean output, string alignment and centering for professional displays, and building complex formatted reports. You used control flow with while loops for interactive programs, if else chains for menu handling, and list comprehensions for filtering tasks. You applied software architecture principles including separation of concerns where task handles individual tasks and task manager handles collections, helper functions for reusable code, and modular design that makes maintenance easy. These are the hallmarks of quality software. Let's discuss common mistakes beginners make with this type of project and how to avoid them. Learning from these pitfalls will save you debugging time. Pitfall 1. Forgetting to save. If you modify tasks but don't call save tasks, changes vanish when the program closes. Solution. Call save tasks immediately after every add, delete, or toggle operation. Pitfall 2. Not validating input. If users enter letters when you expect numbers or empty strings when you need descriptions, your program crashes. Solution: always validate input before using it, check types, ranges, and content. Pitfall 3. Off by 1 errors. Users see tasks numbered 1, 2, 3, but Python lists start at index 0. Solution: always subtract 1 when accessing tasks bracket index -1. Pitfall 4. Corrupted JSON files. If someone manually edits the JSON file and breaks the format, loading fails. Solution: wrap loading in try except and handle errors gracefully, maybe recreating the file. Let's celebrate what you've accomplished. These statistics show the scope and complexity of the task manager you built from scratch. You created 2 classes, Task and Task Manager, each with distinct responsibilities. You implemented over 20 methods covering everything from basic CRUD operations to statistics and file handling. You wrote over 300 lines of well-structured, documented code with proper error handling. You built 8 complete features: add, view, filter, toggle, delete, sort, statistics, and file persistence. This is a substantial, production quality application. You should be incredibly proud. Your application includes full CRUD operations: create, read, update, and delete. It has persistent storage using JSON so data survives restarts. It features an interactive command line interface that's intuitive and user-friendly. It includes comprehensive input validation and error handling to prevent crashes. It offers sorting and filtering to help users organize tasks. It provides statistics and reporting for productivity insights. This is professional-grade software. The patterns you learned building this task manager apply to countless real-world applications. Let's explore how these same concepts power professional software. Note-taking apps like Evernote use the same CRUD operations, file storage, and organization patterns. Library management systems track books and borrowers using similar object structures. Expense trackers store transactions and generate reports just like your statistics feature. Contact managers organize people with search and grouping, same list filtering techniques. Inventory systems track products and quantities using identical data structures. Student management systems, like our previous project, combine all these patterns. The core concepts, objects, persistence, user interaction, power countless applications. You now have the foundation to build any of these. Professional developers test their code thoroughly. Let's discuss how to test your task manager to ensure it works correctly in all situations. Test case 1. Empty task list. Try viewing, deleting, or toggling with no tasks. It should show friendly messages, not crash. Test case 2. Invalid input. Enter letters for task numbers. Numbers outside the valid range. Empty strings. It should print error messages and continue running. Test case 3. Edge cases. Try very long descriptions, special characters like quotes or emojis. It should handle them gracefully. Test case 4. File persistence. Add tasks, exit, restart, tasks should reload. Delete the JSON file and restart. It should create a new empty file. Thorough testing builds confidence your app works reliably. Let's recap the software engineering best practices you applied. These principles make your code professional, maintainable, and extensible. You used meaningful names throughout: task, task manager, add task. Every identifier explains its purpose. You applied single responsibility where task handles individual task data and task manager handles collections. You followed the DRY principle with helper functions that eliminate repeated code. You implemented comprehensive error handling with try-except blocks, validation, and defensive programming. You provided user-friendly feedback with clear messages, confirmations before destructive operations, and formatted output. You ensured data persistence by auto-saving after every modification. You wrote documentation with doc strings explaining every class and method. These practices separate hobbyist code from professional software. Congratulations on completing this project. But the learning journey continues. Here are your next steps to keep improving and building amazing applications. First, enhance your task manager by adding 2 to 3 features from our extension list due dates. Tags or subtasks are excellent starting points that will challenge you without overwhelming. Second, build a similar project to reinforce these patterns. Try an expense tracker, habit tracker, or recipe manager. They all use similar CRUD operations and file handling. Third, add a graphical user interface using tkinter or PyQt to learn how CLI applications translate to visual interfaces. Fourth, learn testing by writing unit tests with ptest or unit test to verify each method works correctly. Fifth, share your work. Put it on GitHub with a comprehensive README explaining features and usage. Share with friends, teachers, or include it in job applications. Your portfolio is growing. Congratulations! You've built a complete, functional command line task manager from scratch. This isn't a tutorial project, it's a real application that you or others could actually use. Look at your achievements. You built a full-featured command line application with 8 complete operations. You implemented persistent data storage using JSON so tasks survive between sessions. You created an intuitive user interface with menus, validation, and helpful messages. You applied professional coding practices including encapsulation, error handling, and documentation. You handled errors gracefully, preventing crashes from invalid input. You organized over 300 lines of clean, maintainable code. This is real software development. The skills you gained are transferable. You can now build any command line application using these patterns. You can design object-oriented systems with proper class hierarchies. You can handle file input-output and data persistence in any format. You can create interactive user interfaces that guide users through complex operations. You can debug and test applications systematically. Most importantly, you can think like a software engineer, breaking problems into objects, planning before coding, and writing maintainable code. These skills apply to web development, data science, automation, and any programming domain. This is just the beginning of your development journey. You have a solid foundation to build incredible applications. The patterns you learned here: object-oriented design, file handling, user interaction, power everything from mobile apps to web services to data pipelines. Keep coding to solidify these concepts. Keep learning new libraries and frameworks. Keep creating projects that solve real problems. Every application you build makes you better. The best way to learn programming is by programming. You are not just following tutorials anymore, you are a developer who can build real software. Go create something amazing. Episode 29 complete. You've built a powerful command line task manager with persistent storage and full CRUD operations. This is your second major final project. You are building an impressive portfolio. Share your accomplishment with these hashtags and inspire others to start their coding journey. Remember, every expert was once a beginner who refused to give up. Stay tuned for more exciting projects. Until next time, keep building and happy coding.